All right, so with these, we're going to go ahead and solve some trig equations with factoring. However, for these, I'm going to go ahead and set all of the intervals that go from 0 to 2 pi. What that does is it only looks at those first solutions inside the intervals on the unit circle. Okay, so we'll go ahead and start with my first one. The first one that I have is 2 times my sine squared of theta minus sine of theta is equal to 0. Okay, so for this piece, I want you to go ahead and think about this as wherever I have the sine squared, think about that as u. And please keep in mind that the sine squared of theta is the same thing as saying the sine of theta when you're going through and doing this. So what you really have here is 2u squared minus u is equal to 0. So this is a type of question where you'd need to take out the GCF. The GCF is u, or if you can go straight forward and thinking about that as the sine of theta, either work. So I factor out my GCF of a u, and I end up with u times 2u minus 1. Remember, you have to put that 1 there. What you're doing when you're factoring out a GCF is dividing by those is equal to 0. To rewrite this in terms of my sine function, that means I have the sine of theta times 2 sine of theta minus 1 is equal to 0. And just like if you were solving this for u, you would need to go through and set both of those equations equal to 0. So now I have two equations. I need to know where the sine of theta is equal to 0, and I get that from this first piece. And then I have my second factor also equal to 0, so that is 2 sine of theta minus 1 must also equal 0. This is from the 0 property. So where does the sine of theta equal 0? That happens at pi. It also happens at 0 and at 2 pi, but if I go back to the interval that I was talking about before, let's look at what the pieces that I have there. What does my interval say? That means 0 is included, but 2 pi is not. So the only two solutions that I want to go ahead and write down for this part of it is 0 and pi. Now the second part of this, I need to go ahead and solve for the sine of x. If I solve this for the sine of x, I add 1 and divide by 2, and I end up getting that the sine of theta is equal to 1/2. Well, where does that happen? That happens at pi over 6 and at 5 pi over 6. And I just went ahead and popped that unit circle back over here. That happens at, so again, that unit circle just gets to be popped right up over here. So that happens at pi over 6 and at 5 pi over 6. Again, really need to know the unit circle very well. I do have a set of flashcards that are on Quizlet that I would strongly recommend. If you don't have these pieces memorized, you start working on those some more. All right, let's go ahead and move on to another example with factoring, only this time we need to go ahead and use. All right, so the next example we're going to go ahead and do is 2 times the cosine squared of x minus 7 cosine of x plus 3 is equal to 0. And I'm going to keep saying this in every one of these because it's so important to recognize the fact that what this really means is 2 times the cosine of x squared minus 7 times the cosine of x plus 3 is equal to 0. And when you do this, we're just going through and substituting. All of this is u. So what do I have here? I need to factor 2 times u minus 7u squared times 7u plus 3 is equal to 0. So this goes back to how do you factor quadratics. So I'm going to go through the way I've always taught it. What I do when I teach factoring, I have 2 times 3, that's a times c, which gives me 6. I need 2 numbers that multiply to 6 but have a sum of negative 7. Those 2 numbers are going to be negative 6 and negative 1. So factoring is just foiling in reverse. So when I set pieces up, it's my first term. Now, if I look at my first term here, it is just 2 u squared, or 2 times the cosine of x times the cosine of x. When I multiply those together, that will give me 2 cosine of x squared. Then what I do is my inside and outside term. My inside and outside term have to have the coefficients that equal negative 6 and negative 1. So if I would take 2 cosine of x, what can I multiply that to give me a coefficient of a negative 6? Well, that coefficient needs to be a negative 3. 2 times negative 3 will give me that negative 6 coefficient that I'm looking for. The next one, that was my outside. My inside piece, cosine of what? Again, I would not need that to be a coefficient of a negative 1. And then check your last term. Is your last term correct? Yes. Negative 1 times negative 3 is equal to a positive 3. So I factored this correctly. So now what we do is we take each of the parentheses and set each of the individual parentheses equal to 0. The first one I have is 2 cosine of x is equal minus 1 is equal to 0. Sorry, I was getting my head ahead of myself, which means where's the cosine of x equal to 1/2? All right, so the cosine of x is equal to 1/2 in 2 different places. It's positive, so I know that has to be in the first and the third quadrant. First place, it is positive. That is just pi over 3. And then down here, I have a reference angle at negative pi over 3, or 5 pi over 3. So my 2 solutions for this first half of the cosine are pi over 3 and negative 5 pi over 3. So the second piece, though, let's take a look at this, because something with this is notable. I have the cosine of x minus 3 is equal to 0, or the fact that the cosine of x is equal to negative 3. Well, that's not possible. It's not possible because negative 3 is outside the range of what any value of cosine can equal. So the final answer that I have for this question is that x only has those 2 values at pi over 3 and at 5 pi over 3. And again, this is because my domain for x is restricted between 0 and 2 pi. Watch the interval notation. This bracket means 0 is included, and the parenthesis means that 2 pi is not included. We're going to do one more with factoring these pieces. So if I have 2 times the sine squared of alpha minus 5 times that sine of alpha plus 3 is equal to 0. This is again a quadratic one where you have to go through and factor it. We're going to go through and rewrite this. Remember that the sine of theta squared, those 2 values here are exactly the same thing. And then this gives us minus the sine of alpha plus 3 is equal to 0. So going back to factor this, again, I take whatever my 2 terms are here, my a and my c, and multiply them together. 2 times 3 gives me 6. My b is my negative 5. So I'm looking for two numbers that multiply to equal 6 and at the same time have a sum that is equal to -5. What are those two numbers? 6 you have to be careful of because this has to be a positive 6. So because that has to be a positive 6, the only two values that can happen, that would be a -2 and a -3. So first terms first. When I'm factoring, it's FOIL, inside, outside, and then last. So my first term here is 2. So that becomes 2 times the sine of alpha. Oops, I'm at the infinity symbol there. So 2 times the sine of alpha times the sine of alpha. Now, what about my inside and my outside? My inside and outside, those two products must have coefficients that equal -3 and -2. So 2 sine of alpha, I need to multiply that times a -1. That'll give me -2 sine of alpha. And then inside here, I used up my 2, so the next one, this has to equal a -3. And if I check my last term is the same thing, -3 times -1, which gives me the +3 that I need. So to go through and finish solving this, all I have this is 2 sine of alpha minus 3 is equal to 0. And then the sine of alpha minus 1 is equal to 0. I want to go ahead and solve this for the sine of alpha. So if I go ahead and solve this for alpha, that gives me that the sine of alpha is equal to 3/2. Now, remember what we talked about before. This is outside the domain. I can't have this, so there's no solutions here. Over here, I have where's the sine of alpha equal to 1. All right, and then it gives us that alpha is just equal to pi/2. That's it for solving these trig equations with factoring.